That's the end of that 7-mark question. And question 9, so this paper just keep on going and going and going. Question 9 is about carbon-13 NMR. So carbon-13 NMR, this is for compound A, which is C8H8O2. Better write that properly, otherwise I might not be able to read my own handwriting. There are 6 peaks. So there are 8 carbon, but 6 peaks. So that means there's a bit of symmetry there that we need to keep an eye out for, because by right 8 carbon would mean if all 8 are different, I should get 8 peaks, I get 6 peaks, meaning that some of them are chemically equivalent. Now what can I say here? There's no question here, it's just, I don't know why there's no total for this question, because it's just 6 marks for this one page and that's the end of the paper actually. Oh well, never mind. So what else do we know? Information. A reacts with bromine water. Bromine water means aqueous bromine, and you get B which is C8H6Br2O2. So A previously was C8H8O2. You can hopefully see that this is addition. This is an addition because 2 things become just 1 thing. The number of carbon, it remains the same. The number of hydrogen has decreased actually. Wonder why. The number of hydrogen has decreased. The number of oxygen is the same. The number of hydrogen decreases. So you have replaced or you have substituted 2 times hydrogen for 2 times bromine. So I was wrong. This cannot be addition. This must be substitution based on my discovery that the number of hydrogen gets down. So you decrease in the number of hydrogen, which means we do kick out HBr. We kick out 2 HBr. This is a balanced equation. This is your substitution reaction. This probably means it's going to have a benzene ring because this is going to be electrophilic substitution mechanism. This is not common of alkene chemistry. Not just any alkene, but this is going to suggest aromatic, meaning it has benzene ring. So benzene chemistry, not carbon-carbon alkene. At least that's my take from this first information here. So how about the second information given? The second information given is A reacts with alkaline aqueous iodine. Alkaline aqueous iodine is the test for iodoform. So A is C8H8O2. And what does they give you? They give you a yellow precipitate. So this yellow precipitate is the easy thing because this is triiodomethane. So triiodomethane is the positive result that come from the test, okay, the test of which it is positive test for CH3CHOH functional group or CH3C double bond O. So I need a bit of space there. CH3C double bond O. It's N or because this thing come in AS under alcohol topic, this thing come in AS under carbonyl topic. So going back to what I can say about D, so they haven't mentioned about D yet, but your carbon has to come from here because you are not adding carbon, you are chopping up, you are fragmenting the carbon from the main thing there. So it's got this or the other thing. What else can I say? So well, I can say that they must have this group or this group such that they will react with that. How about observation number 3? Compound D reacts with PCl5 and you get compound E, which is C7H5O2Cl. This is convert, or you get the alcohol. In fact, it's not just alcohol, it could also be carboxylic acid to basically convert the OH. Convert the OH of alcohol or carboxylic acid to Cl. So basically, if you have alcohol, then you will get halogenal alkane. If you get carboxylic acid, you get acyl chloride. Okay, but here you have 1 chlorine. So what does this tell you? So this is just single conversion. Single conversion would mean only 1 time OH in D. But this OH cannot be a phenol. It has to be either alcohol, which is not phenol, so it cannot be phenol because phenol doesn't do this reaction, or it could be carboxylic acid. At this stage, we can't tell much, but you can hopefully tell that, 7 carbon. So I can work backward now. 7 carbon. Previously, I have 8 carbon. I cut away 1 carbon. So this is going to be 7 carbon because this information tell me that there are 7 carbon here in D. And that's very, very important. If I have to work backward, which is basically this line here in green, work backward. So remember, we are replacing one single OH with Cl. So what I'll do is I'll cut out. So D is going to be C7. I am, excuse me, I remove the Cl and I add in the OH. Then I'll have H6 because I have 1 extra hydrogen. And I will remove the OH just now, so I have O3. So D is going to be that because I removed the OH and replace it with Cl, so I remove 1 H, that give me 5, I remove 1 O, that give me 2, and then replace the OH with the Cl, so it's just 1 hydroxyl OH group, which could be carboxylic acid or alcohol. We don't know that at that stage, we just know that 7 carbon and 1 carbon, because that give me 8 carbon in A before I reacted it with alkaline aqueous iodine, which chop off 1 carbon as a result of the presence of either of these groups that actually give me this positive iodoform test. Anyway, so moving on to the observation number 4. What other information can I derive from this? E reacts with propan-2-ol. So what is propan-2-ol? Propan-2-ol is this, 1, 2, and 3. And I get this compound F. Is F given? F is not given. What do I know? I know E. I know E has this chlorine there, but it reacts with alcohol. Halogenoalkane does not react with alcohol. Halogenoalkane does not react with alcohol. RX halogenoalkane. No reaction with alcohol. No reaction with alcohol. So the fact that this thing reacts with alcohol and you have alcohol there, so most likely we are looking at condensation reaction. This condensation reaction between alcohol and something, condensation reaction means this F is going to be an ester containing C double bond or like this, and this implies that, so this brings back to the idea that E must contain acyl chloride and not a halogenoalkane, okay? Because if it's halogenoalkane with this, no reaction, so it must contain acyl chloride. If E contain acyl chloride, so if E contain acyl chloride, that means D, therefore D is a carboxylic acid. Therefore D is carboxylic acid. So C point number 4. Okay, so if E is acyl chloride, so therefore D is carboxylic acid. And D is carboxylic acid, and that makes sense from there, because when you cut through the alkaline aqueous iodine, you're going to end up with a carboxylic acid terminus. Actually, it's under alkaline condition. You do actually get the salt, but you do protonate it with excess water, and then it will give you the carboxylic acid there. What else? Now draw the structure of compound A, B, C, D, E, and F. Let's try. Okay, let's try. Now, looking at question 9 again, at the beginning, we say C8H8O2. This really reminds me of there's a benzene ring, as we said just now, aromatic of benzene ring. So perhaps I can start by drawing a benzene ring. I cannot, can I? Let me think. Can I have a OH? Maybe I have a OH, or maybe not. I have 8 carbon. So 8 carbon, but I have symmetry. So perhaps that is correct. Could be that. Could be this. Like that, symmetry. So let's work through it and see. This is 1, 2, 3, 4, 5. There are only 5 peaks there because there are 5 different carbons. But these are just carbons. These are not even the one with the oxygen. So I haven't dealt with the oxygen yet. Just looking at the carbon, so there's a symmetry there. These and these are different, these and these are the same, these and these are the same. So 1, 2, 3, 4, 5 cannot be these. This is a 1, 2, 3. There are only 3 peaks there, so cannot be that as well. So perhaps it's something like this. Not too sure really, not too sure. 1, 2, 3, well, there's a symmetry down there. So 1, 2, 3, 4. We're looking for 6 peak. I think we can't really start from just this thing. We have to consider the O2 there as well. So, you know, those things are not going to be useful. I'm just going to rub them out. Okay, so let's try and think about this again. Okay, so we know we have benzene ring, definitely. We have benzene ring. We know we have this thing, which is this alcohol or this C double bond O. We know that this is carboxylic acid because it could go there. So now I have 7 carbon. And if there is 7 carbon, this D here must be 7 carbon as well. Which you said D is 7 carbon. And there is a benzene ring and there's a carboxylic acid. So this one has benzene ring, and then this one also have carboxylic acid. So that should give us our 7th carbon, because 6 carbon from the benzene ring and 1 carbon from the carboxylic acid. So there has to be 7 carbon there. So I can probably start from D. So let's see where I can start from. So we're going through analysis, right? So if I start from D, D just now was a 7 carbon carboxylic acid. So 7 carbon carboxylic acid. But what is the formula of D just now? So we work out from here. We could go backward, where we take away the Cl and we add in the OH, because the OH in D get replaced to give you this acyl chloride, as I said. So C7H6O3, C7H6O3, this should be D. Let's just double check. We have 6 carbon, 7 carbon. We have 5 hydrogen, plus 1 is 6 hydrogen. We have 2 oxygen, but here is 3 oxygen. We have 1 more oxygen, which cannot be there. And if we have 1 more oxygen, then it cannot be ester. It has to be alcohol. But the alcohol cannot be here because this is carboxylic acid. So it's got to be a phenol. Okay, so it could be this, or it could be this, or it could be the other possibility where it could be that. So there are 3 possibilities here. So which one is D actually? We have to think about it. So all of these could be D, but I don't want to go here, because if I go here, it's the exact same thing as that. If I go here, it's the exact same thing as that. So it could be either of these 3 positioned. In terms of the position, I think that is where this information will come into play, which is the NMR peaks. So we have to try and work backward. So if I have D as one of the 3 possibility, and then I have A has C8H at O2, I need to try and put in, is it this group or is it this group? A is C8H8O2. A is going to be C8H8O2. Am I correct? C8H8O2. I have a positive iodoform test. So I have a positive iodoform test. So remember, when I have a positive iodoform test, I will cut off the CH3CO or the CH3CHOH. So it has to be the other thing. It has to be the carboxylic acid that actually give me the original group there. So perhaps I am looking at CH3CO like this, or could I be looking at CH3CHOH? So it depends on really which one are we looking at. Are we looking at CH3CO or are we looking at CH3CHOH? I don't want to draw for these and these first, because I just want to work out the identity of A first. Is it going to be this alcohol? Is it going to be this ketone here? So let's try and work out the molecular formula. So there is 6 carbon, 7 and 8. So this is C8H. There is 1, 2, 3, 4. And then there's 5. And then there is 3 hydrogen there. So there's 8 hydrogen. And there is 2 oxygen. So this is C8H8O2, which means this cannot be C8H8O2 because there's an additional H there, and there's additional H there. You can try and work it out. So C8, but then the hydrogen will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there will be 10 hydrogen and O2. So this is not A. So meaning to say it is not CH3 CHOH, but it is a CH3 C double bond O. So having said that, if that is the one that give me positive iodoform test, I then need to think about which isomer is that. So cannot be these, so it has to be these, but then I need to also decide if this is A could also be the other one where the OH is there, and then I have CH3CO like this. A could also be where the CH3CO is on this carbon here, and then the other OH is on that carbon. So all of these could be A, which is C8H10O2, so there's A. Alright, so now we have to use the NMR information. The NMR information told us that we have a bit of symmetry, but not a lot, because 8 carbon give me 6 peaks. 6 different carbon there. Okay, so let's have a look at these options for A, where we work backward from there. So 6 different carbon. Hang on, I want that in green, I want that in red. 6 different carbon. So there's 1 carbon, 2 carbon, so I'm on this one at the moment. 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5, 6, 7, and 8. There are 8 different carbon there because there's not a lot of symmetry. So let me just show you for the other one. If I use a different color, so let's say I use pink. So 1, 2, 3, 4, 5, 6, 7, 8. There are also 8 carbon. So what in the world are we looking at? Okay, forget about it first. What about the next ones? Let me use a different color, brown color. So there's a plan of symmetry here. I hope you can see that there's a symmetry in between there. So definitely these and these are the same, and then the pink one and the pink one are the same, and then you have a blue one there. It's different from this black one here. So there's one, I should probably use a different color to show that much better. Orange one, for example. So you got 1, 2, 3, 4, and then 5 and 6. So you got another 5 and 6, 5, and you got another one which is 6 there. So there's no other carbon, so there's 1, 2, so these and these are the same, these and these are the same, 1, 2, 3, 4, 5, 6. So there's 6 different carbon. So we're looking from that NMR information, we're looking for something that has 6 carbon environments. This one has 1, 2, 3, 4, 5, 6, 7, 8. Remember, this one has 8 different carbon. I shouldn't have to count again based on what I have just done previously. So we know that it cannot be these. We know it cannot be these because these have 8 carbon environment for that compound A there, for that molecule A there, which also means that this cannot be your D, which means we are looking for this as being your A, and we're looking for this as being your D. Okay, so going to all that information, so I can just we can just start fresh, and let's have a look at your table again. So this is a 6-mark question. In ideal situation, you're probably not spending this much time actually, like going through all the thing that I've just mentioned, because you would be working a lot faster in the real thing, because all of these are just basically how to help people in general to try and understand the underlying analysis. This is the last question as well, so some students might even skip the very last question because they have no idea on what to do at all. This is C8H8O2. So we can now work forward. So this is your alkaline aqueous iodine. Ideally speaking, in your alkaline condition, you actually get carboxylate salt. So this is your yellow precipitate, which is C there, and then this is D, which I just talked to you about. Ideally speaking, if you are in a alkaline environment, not just the carboxylate there, but also the O of that hydroxide should be O minus, and then this one will be C C double bond O or minus like that, because you are in alkaline environment. Phenol is weakly basic, weakly acidic, that's why it will be deprotonated by alkali, and this thing is a carboxylic acid that will be deprotonated by the alkali. But seeing how compound D can react with PCl5 in the later stage, I assume they do actually protonate this at the end, such that we are not expecting the carboxylate to be around. So we're just expecting D to just be the carboxylic acid, which we can then react with PCl5 to try and turn that into acyl chloride, like that. Don't forget your OH doesn't turn into halogen alkane because it's a phenol and not a normal alcohol. And of course that will react with your, that is E there, so that is C7H5O2Cl. That will react with propan-2-ol, which is an alcohol. The alcohol will react with the acyl chloride to give you an ester, not the alcohol on the benzene, so the phenol doesn't react, but that acyl chloride will lose the Cl, this will lose the H, so that will be combined with the O, and then you have the branch group there because it's propan-2-ol. This is your ester F there. Going back to the original structure, we talk about the reaction with Br2. Actually, we haven't talked too much about the reaction Br2, but you know this is definitely correct based on the amount of NMR peak. You know that with Br2, the OH directs to this position, which I've marked in blue, but this position in blue, this one is blocked because there's something there already. That is why it only results in 2 times substitution instead of 3 times substitution. So that is why your final product only has 2 bromine in it instead of 3 bromine, because the other ketone is still present. That's why B is C8, H6, Br2O2. And we know this is a substitution because earlier on I did actually try and look at it. We saw there's a decrease in the number of hydrogen. If it is addition, there will be no decrease in the atoms. You're just adding Br2 onto the normal double bond, but this is electrophilic substitution on the benzene ring. Because you want to go back to being aromatic, you will substitute the hydrogen on the benzene ring with the Br as a result of very, very strong activating effect. So this is called activating effect of the phenol or the NH2 group, and they direct to position 1, 3, and 5 there. Okay, so that is B there. And I think we come to the end of this particular question. So I've got everything sorted out here, A, B, C, D, E, and F. And yeah, I mean, I explained through the whole questions in our analysis prior to actually showing you this stage here. Yeah, I hope that was useful. So don't forget to click the button on the bottom right to subscribe to the channel, and if you think this video is useful, so do leave a like for the video and share the channel widely with all your friends, chat group, juniors, seniors, and many other people. In time, more tutorials will come, but it does definitely take time to catch up to this kind of full paper video tutorial, especially in this restructured format where I don't show the question paper anymore as a result of copyright issues that Cambridge has with my previous videos. And don't forget to actually follow me as well at ptet.chemistry. There's at ptet.chemistry on Facebook, Instagram, and Twitter to get connected, send in messages and queries and whatever. Okay, so see you in the next tutorial video. Thank you for watching.